The fourth one I gave you to do read 10 of 60. 10 of 60 degrees is equal to, now 10 is y over x. Of 60 degrees, y is root 3. X of 60 degrees is 1. So my answer is just root 3. Number 5, cos of 30 degrees is equal to, now cos is the function x over r of 30 degrees. Our x value is root 3. Our r value is 2. So our answer of cos 30 degrees is root 3 over 2. And won't that be the same as sine 60 degrees? Sine is the function y over r. Y is root 3. R is 2. That's just for interest's sake. You can work this out on a calculator if you want to, but remember that when we are working with special angles, we are trying to do it without the use of the calculator. So even if you're using the fancy Casio calculator that gives it to you in natural display, I don't want you to use it. Use the table when you are working with special angles. In the next 5 examples that I gave you to do, I want you to work out what theta was if we have cos theta is equal to, or sine theta, or tan theta. Cos theta is equal to root 3 over 2. That's the first one I gave you. Again, before you get started with it, now if you've already written down the table, you don't need to rewrite it. But our special angles are 90 degrees, 60 degrees, 45 degrees, 30 degrees, and 0 degrees. X values 0, 1, 2, 3, 2 and 3 in the square root, and square root 4, which is equal to 2, 2, root 3, root 2, 1, 0. R is always equal to 2. Sine is the function y over r. Cos is the function x over r, and tan is the function y over x. Cos of theta is equal to root 3 over 2. That means that theta is equal to, now cos is x over r. Where do we have an x value of root 3 with an r of 2? That happens at 30 degrees. Number 2, tan theta is equal to 1 over root 3. That means that theta is equal to what? Tan is the function y over x. When is our y value 1 with our corresponding x value root 3? That's also at 30 degrees. Number 3, cos of theta is equal to 1. That means that theta is equal to, now if cos of theta is equal to 1, isn't 1 the same thing as either root 2 over root 2 or 2 over 2? We're going to be working with 2 over 2 in this case. When is our x value 2 and our r value 2 as well? That's of 0 degrees. Number 4, sine theta is equal to root 2 over 2. That means that theta is equal to, now sine is the function y over r. Root 2 over 2 y over r happens at 45 degrees. The next one, number 5, I'm just going to write it in over here. Number 5, sine of theta is equal to 0. That means that sine of theta is equal to 0 over something. Sine is always y over r. When is our y value 0? At 0 degrees. That means that theta is equal to 0 degrees. We are now going to move into some more complicated type of examples that involve the use of reduction as well as special angles. Have a go at the following examples, and when you return, we'll go through it together. The first one I gave you to do read sine of 225 degrees. Now before we get started, this is going to be dealing with special angles, so again I'm going to put down my table of special angles: 90 degrees, 60 degrees, 45 degrees, 30 degrees, sorry, not 15, and 0 degrees. X values of 0, 1, 2, 3, and root 4, which is equal to 2, 2, root 3, root 2, 1, 0. R is always equal to 2. Sine is y over r. Cos is x over r. And tan is y over x. Now, sine 225 degrees is the same as sine of 180 degrees plus 45 degrees, which is equal to negative sine 45 degrees. Negative sine 45 is equal to, now, sine 45 is y over r, which means that sine 45 is root 2 over 2, except it's times by a negative on the outside, so it's negative root 2 over 2.